Live from the Aurora is made possible in part by NASA, the National Aeronautics and Space Administration. Auroras are some of the most beautiful and instructive of all natural phenomena. They are the most visible symbol of our planet's close connection to our local star, the Sun. But unless you live somewhere close to the Arctic or Antarctic, they're rare occurrences. And research on auroras using sounding rockets to actually fly through them is dangerous work, normally done off-limits to visitors. But on 2 nights in early 2003, young people all across America, in Atlanta, Georgia, Oakland, California, Baltimore, Maryland, and Anchorage, Alaska, had the chance to witness the aurora up close and in real time. Young viewers met NASA's chief scientist, Shannon Lucid, record holder for time spent in space by a female. Range manager Greg Walker talked to them live from a blast-proof bunker. They explored science, sounding rockets, and how young people could get involved. Now you can share the experience via video and the internet as part of NASA's Sun-Earth Day 2003. This is what it looks like to be live from the Aurora. Passport to Knowledge, public television's longest-running series of interactive learning adventures, in association with KUAC TV9 Fairbanks, Alaska, present Live from the Aurora. Poker Flat Research Range near Fairbanks, Alaska, is the largest scientific sounding rocket launch site in the world. It looks out on miles and miles of sparsely populated mountains and forests. Prime time to study the aurora is midwinter, when skies are clearest. Down in the valley are warm buildings in which to assemble the rockets. And 5 launch pads, 2 covered by giant removable shelters. High up on neighboring hills, radar dishes and special mobile launch control rooms, as well as the Neil T. Davis Science Operations Center. The teams of men and women it takes to ready the rockets and launch them come from all across America. This is the climax of years of effort. Oakland, California, the Chabot Space and Science Center. Here, too, they were getting ready. Their night started with hands-on activities, exploring the colors of the aurora. Students, parents, and caregivers heard from Berkeley's Isabel Hawkins about how Earth's magnetic field helps create the northern and southern lights.
And this is the north and south magnetic pole.
And, as at all good science centers, there was lots to touch and sniff and experiment with.
See, can't you see it?
Getting ready at Poker Flat is a little more risky. Here, technicians in full-body fire protection gear prepare the chemicals which will help reveal some of the aurora's secrets. Here, hands-on work means tests to see if the rockets and payloads are ready.
Yeah, Roger. Once we get
One of the missions that's about to launch has brought a team of undergraduate assistants up from Clemson University, South Carolina. Their jobs include assembling and calibrating the cameras that will track their rocket's journey through the aurora. In Anchorage, Alaska, at the Imaginarium Science Center, they built special spectrum glasses to help them understand the aurora. Another big hit was the Van der Graaf generator. Static electricity makes fine hair stand on end. It works especially well if you're made of plastic. Later that night, the youngsters would see how electricity also shapes and colors the aurora. But first, to keep them going, pizza. Just before launch at Poker Flat, those protective shelters are rolled back, and the rockets, covered in styrofoam insulation, are angled up into the cold, dark sky. The teams run practice countdowns.
5, 4, 3,
Item 31.
item 42, 0.
If the weather cooperates and the aurora is bright, tonight just may be the night. Time to wake up in Atlanta, Georgia. It's 5 a.m., the best time for the aurora. Not the best time for many teenagers. But fortified by special aurora-colored cookies, they're also good to go. Orbiting Earth, NASA's polar satellite shows there's an aurora building. Soon it may be right over Alaska. It's also 5 a.m. in Maryland. Time for a few deep breaths to wake up mind and body. Now it's showtime. This is what that night's aurora looked like from space. And this is what we all saw, live from Poker Flat, Alaska.
Welcome to Poker Flat, Alaska. Welcome to the Aurora of Alaska. What you're seeing is a spectacular show. This is live Aurora. I'm from about 30 miles north of Fairbanks, Alaska, and the aurora you're seeing is north of me. This is real aurora from our very fancy special television camera that lets us do this. We're going to have a wonderful program today. Hopefully you'll have lots of questions arise from what you see, and I hope you'll appreciate this very rare treat. We've been having a wonderful, spectacular display of aurora the last half hour. It's fading a bit now, and I'm quite sure it'll rebuild and we'll get a spectacular display very soon.
Thanks, Dan. You're putting on a spectacular show for us. Thanks an awful lot. I'm Art Poland, a solar physicist from Goddard Space Flight Center, and we're here at Poker Flat tonight to watch the aurora live and to hopefully launch a rocket into the aurora to make some measurements on it. My co-host tonight is Nikki Fox.
Hi, I'm Nikki, and I'm from the Johns Hopkins University Applied Physics Lab. And yes, as Art said, it's all excitement here. We've got rockets on the pad, we've got aurora overhead, so we're hoping that you're going to enjoy a great show with us. Before we get started, I wanted to introduce you to some of the people that will be joining us this evening. Over here are our students from Clemson. This is Jennifer and Justin and Brian and Chris and Tyre, and they are all here supporting one of the rockets that's actually on the pad tonight. This is Neil, who will be showing you some science and physics as we go through the evening. Jan is going to be giving us up-to-date information about what's happening outside. And the voice that you just heard at the beginning of the show, this is Dan, and he's going to be giving us up-to-the-minute information about the aurora. So we're all very excited here.
We also have Greg Walker over in the blockhouse where they launched the rockets from. Greg?
Hi, I'm down in the mission support room here at the blockhouse tonight. And with me, I've got Tracy Gibb, who's the mission manager here on the HEX program. Can you describe what you're doing down in this room?
Sure. Hi, as Greg said, my name's Tracy Gibb, and I'm a NASROC mission manager. I manage 2 of the missions that are right now staged on the launchers for launch. This particular room during launch operations is extremely busy. All the team engineers and technicians operate, maintain, and basically monitor all the payload systems from this room. If you can see behind me right here is some of the equipment that we use to monitor those systems. During the launch countdown, the final minutes of the launch, we monitor all the systems, make sure everything is operationally acceptable, and then give a final go for launch.
So back to you, Art.
And I'd also like to introduce Shannon Lucid.
Hello, my name is Shannon Lucid, and I'm here representing NASA. And as you, I hope, are well aware, NASA does a lot of scientific research. And the tool, one of the main tools that NASA uses to do the science research is rockets. And they use rockets from the very large rockets like the Space Shuttle to very small rockets like the sounding rockets. Now, I have never had the opportunity to see sounding rockets and see how you put a sounding rocket together. So I am really thrilled to be here at Poker Flat watching this entire operation to see how the sounding rockets are put together and how they work. And it's just so interesting to see how every niche of science research has its own specific type of rocket that can go and carry out this research.
Thanks. We've got some tape we want to show you what it's like around here at Poker Flat in the Fairbanks area.
From space, satellites show us the northern lights ringing the Arctic regions like a crown of fire. Let's get down to Earth and find out a little more about Poker Flat Research Range and Alaska. Our program was originating from close to Fairbanks in the interior of Alaska, America's largest state. Fairbanks is a city of just over 80,000 people. This day, the high was 4 degrees. At nights, it's often 20 to 30 below. Each year, Fairbanks hosts an international ice carving festival, during which artists create intricate frozen sculptures. The ice is so clear, you can see through 4 feet as if it was 4 inches. The Chino River in downtown Fairbanks is also the finish line for an annual sled dog race, the Yukon Quest. They call it mushing, harnessing sturdy dogs in teams of 10 to 12 and setting off cross-country. Mushing is, in fact, the official state sport of Alaska, and the sled dogs are very well treated. But Fairbanks is much more than ice art and mushing. The University of Alaska, Fairbanks, is a major research institution and home to the Geophysical Institute, one of the world's leading centers for research on the Aurora. The internet links this place to everywhere on Earth, but to get to Poker Flat, you have to drive. You pass gold mines that brought wealth to a lucky few in the 19th century. But this is where much of Alaska's wealth comes from today. Black gold, oil, running through the Alaska pipeline from the Arctic Ocean to the Pacific at Valdez. But we've still many more miles to go. This is where we're headed, the Poker Flat Research Range, operated for NASA by the Geophysical Institute. Security is high. Everyone needs to check in at the main office. This is a special time of year, as well as a special place. We're so far north that daylight is growing by 7 minutes every 24 hours. As each day ends, it's time to get ready to view the Aurora. And if you're very lucky, to launch rockets to study it close up.
Well, as you can see from that film, it's really beautiful up here, and I've been having a blast, actually. We have 2 groups of you out there listening to us. The first is April. Could you describe to us who's there, what you got?
Hi, Art. It's April in Atlanta. We're at Fernbank Science Center. We're at Fernbank Science Center, and we're working with groups of students from DeKalb County. We are practicing what an aurora looks like. You ready, guys? And we've been working on aurora cookies. We've got a whole display here of the various shapes, and we're also working with a local artist, Edith Kelman, and some of her students with their aurora sculptures as well. Those are in the Planetarium Theater, and that's what we're going to be working with you guys over the next couple of hours. Back to you, Art.
That's great. How many students do you have there?
We have about 24 that are awake, and a couple that are still snoring.
Okay, and we have another group here at the Imaginarium, Lincoln.
Hi, this is Lincoln from the Imaginarium. We have 30 excited students, all from around the Anchorage area. It is just a couple minutes after 1 o'clock, so we're a lot more jazzed up. Can we hear from the crowd? All right, well, we've got a ton of aurora hunters. We're surrounded by beautiful photographs of the aurora, and we have a scale model of the Hex rocket, so we have nothing but aurora and rocketry on our minds today. Is that right, guys? Okay, well, back to you, Art. Thank you.
Well, you guys sound about as excited as I've been the last few days seeing the auroras for the first time. Baltimore, can we hear you now, or can you hear us?
Hello, Art. We're here in Baltimore, and I'm Claudio Minutes. I'm talking to you from the Maryland Science Center. We are here with families, teachers, and students from the Roland Park Middle School. It is 5 in the morning, and the weather is very cold. After preparing for weeks, we are ready to launch the rockets. We can wait for the Aurora, and we're psyched to be part of this special program.
Well, you know, I actually was lucky enough to meet these kids in Baltimore just a few weeks ago. So I want to say hi to all the kids from the Roland Park Middle School and to their teachers, Lisa and Georgia. And we'd also like to welcome Elaine and Troy, that were the organizers of this year's Sun Earth Day 2003. So can we have a big hello from Baltimore?
So live from Baltimore is live from the Aurora!
Okay, so we'll leave Baltimore for a moment and we will check in with our other remote site this evening, and that's Oakland, so the Chabot Science Center. Can you hear us?
Yeah! Can you hear us?
Can you hear us?
Yes,
Oh, yeah,
we can hear you. Hi, Oakland. I guess you guys don't have any snow there, so you don't have a problem like we do.
No, we have a beautiful, clear evening. The stars are out here. And the auditorium is full of eager faces waiting to see the Aurora.
So how many people do you have there, Ben?
I think over 100, certainly.
Wow. Well, welcome to the show.
Okay.
Thank you.
Hey, you know, before I came up here last week, I had never really seen the Aurora live. And, you know, like I said, coming up here, it was just amazing. And you really need a guide if you want to see the Aurora. And I've been really lucky to have Jan Curtis here show me the Aurora. And, you know, like, you can look at it, for example, for a little while, and then it fades away, and you say, oh, shucks. And you say, I'm going to go in. And Jan says, no, Art, hang on a couple minutes. In 10 minutes, it's really going to light up. And he's been telling me when to watch. And he's really an expert, so I'm going to let him tell you guys.
Well, watching the Northern Lights, especially from Fairbanks, where it can be seen almost 248 days a year, quite remarkable. These photographs that you're seeing now were actually taken just a couple of days ago at our hotel in the middle of downtown Fairbanks. Other days I've taken where we went out into the outside the city limits and were able to capture even more spectacular Northern Lights. One thing about the Northern Lights are that they do change color, they change shape. They can last anywhere from 1 minute to several hours, as we're having an experience tonight. And it's very, very exciting to watch. You never know what to expect, but patience is the key.
Okay, and as you say, Jan, we've got tremendous Aurora here tonight. So, of course, the other great thing is it's a very interactive show, and you get to interact with us. So we're going to start off with our first question period. Oakland, do you have a couple of questions for us?
Okay, hi, my name's Jennifer and I'm in the 10th grade. I was wondering if auroras occur more often in certain seasons.
Oh, well, yes, that's a very good question. Actually, the aurora will occur slightly more around the equinox season. So we're coming up to that now in March. That's when every single place on the planet has exactly the same amount of daylight hours, 12 hours everywhere. Yes, the aurora will happen more frequently during that time, both in the spring and in the fall. So that's a great question. Now, do we have another one for maybe for Greg down in the blockhouse?
Hi, my name's Ariella and I'm in 6th grade. I wanted to know how high can the sounding rockets go and what happens when they reach their limit.
The missions we have tonight are not going as high as we often shoot. Sometimes we can get to 1,100, 1,200 kilometers. That's like 700 or 800 miles up. When they go that high, they'll land out in the Arctic Ocean, on the ice cap of the Arctic Ocean. Much of it will burn up and be destroyed on re-entry.
Are some colors more dominant than others in the Aurora Borealis?
Actually, I'm going to throw that one to Dan to answer because he's got those great movies that he just showed you. So Dan, are there any colors that are more prominent in the aurora than others? Yeah.
Green is the primary color in the aurora. It's caused by electrons striking oxygen atoms, a single atom of oxygen, not the two linked pairs of oxygen we breathe down here at the surface of the Earth. And the other primary color is that red in the upper reaches, which is also caused by oxygen, but the difference between the green and the red is that the really energetic particles penetrate further and make the green, and the lower energy particles make the red. There's also some reds and blues from nitrogen. But the green is the primary color.
How fast did the auroras move once they hit Earth?
Okay, if you're talking about how you actually see it in the sky, it moves probably a couple of kilometers a second. They actually move very, very quickly when they're going, but you will often see the aurora just literally hanging there and not doing very much at all. So you do see a lot of different timescales in the aurora. One thing is that the actual particles that are causing the aurora, it takes about 10 minutes from them to get from deep within our magnetosphere down into the atmosphere to start causing the aurora, and then they move very quickly through the atmosphere, making it glow. But the actual sideways motions that you see are usually about a couple of kilometers a second.
What I'd like to do now is go talk to Mark Conde, and he's going to show us how his rocket works.
My experiment is rather different. It's something that NASA hasn't attempted before. We're going to try and reorient the rocket during flight, and so the sequence of events is rather complicated. So I've got a little model of the upper sections here. So after that first stage burns initially after launch, that drops away. Then this second stage, this Black Brant 5 will ignite and burn, and then the vehicle will coast up to about 80 kilometers in altitude. When it reaches 80 kilometers, the nose cone here will be ejected off the top there. Now at 80 kilometers altitude, the atmosphere is thin enough that it doesn't matter that this thing's fairly blunt on the front anymore. Shortly after that, at about 88 kilometers altitude, the Black Brant 5 will drop away like that, leaving a section that looks like this. Now at the top of this section we have a bottle of compressed gas with little thruster nozzles on it, and they will start firing so that this thing, which was travelling vertically, will start to tip over on its side like this. And it'll come over to an angle something like that, about 15 degrees angle, and then at that point this third stage, this Nika, will ignite and send the thing off, basically travelling sideways, not completely sideways, and it will follow a flat curving trajectory like this. Once this Nika burns out and completes its burn, then these two pieces will separate again like that. There's a compressed air piston in there that pushes them apart. As soon as that happens, this front section with the attitude control system on it will tip itself on the side like that, and then the two pieces will fly along in this sort of direction. Now the reason that we separate these two is that the back portion of the rocket here has a canister with a chemical called trimethyl aluminum that this canister will start to release. And that burns slowly in the atmosphere and leaves a visible trail. And it's that trail and the movement of that trail that we're really interested in. We want to photograph that from the ground from a number of sites and triangulate it. And by watching how that trail moves, we can measure the wind. In the meantime, this front section, which is reoriented like this, will be spinning, and it has several instruments on board that scan out from the side of it as it spins and look at the aurora and make measurements of the aurora and make measurements of the plasma in situ as it flies through. So from this section we can, by photographing from the ground, we can measure the wind, and from here we can make measurements of the aurora that we fly through. We're trying to fly this whole thing through an auroral curtain as we go. And so that's basically the experiment, to measure the winds and to fly through an auroral arc. It will look very spectacular from the ground.
Well, what we've got now is a video that'll show you how the rockets are made, how they're put together.
NASA's Wallops Flight Facility on Virginia's eastern shore. It looks like a factory, but inside they're building rockets. You start with a long, hollow tube to hold the payload, fuel, and motors. It has to be strong, but as light as possible.
On a normal application, we usually bring this down to about 1/8 of an inch thickness. It really depends on what kind of altitude you're looking at in the flight. We custom the skin thicknesses so that the motor that's being used in the application will achieve the right altitude.
It takes days to machine the rocket's walls down to the right dimensions. But you need weeks and months of skilled labor to build all the many different parts, every one of which has to work right first time. Wallops in fall was warm and sunny. By the time everything got to Poker Flat, it was cold and midwinter. Trucks needed chains. Inside Rocket Assembly Building C, the first stage motors were waiting. Marty Martinez's job is eventually to push the launch button, but he also supervises the entire process of getting the rockets to the launch pad. It's all done carefully, slowly, safely. They shut down roads. The convoy inches along. The scenery's great, but they're here to work. The launch pads are off limits to all but essential personnel. But this day, they allowed our cameras inside. Rockets carrying sensitive instruments get their own heated shelters. When it's time to launch, the whole structure will roll away. At this critical stage, machines only get you so far. It takes humans for the last few feet. Doing rocket science takes physicists with PhDs, but also muscle power and great care. With Marty at the controls, the first stage is carefully lifted up to what's called the rail. Mark Conde's rocket is nearly there. That sturdy peg you see on top will attach the rocket to the rail and guide it off the launch pad. A flight of several hundred kilometers begins with a journey of a few inches at a time. Once more, Marty's in the driver's seat. Ground Safety Officer Jack Smith checks out every detail. Mission Manager Tracy Gibb sees years of effort come together. Paul monitors every millimeter.
Well, we'll take it too. That's good enough. We have a problem.
Even a rocket needs to stay warm. They cut custom openings in what's going to be a thick styrofoam coat. Now it really is the last few inches. Man hauling all the way. Mark Conde, say goodbye to the first stage. It's going to be covered up until launch, when the styrofoam blows harmlessly away. Temperature sensors run back into the blockhouse. The rocket's health and safety is monitored 24/7.
It went on without a hitch. A couple minor problems, but nothing to stop us. Everything's done. We're ready to roll.
So now you know how the rockets stay warm at Poker Flat. How about the humans?
And then, nothing gets cold. I can still see, as long as you don't breathe.
Okay, great. Do we have some questions from Anchorage?
How long does it take the rocket to get to the destination?
Well, it will be, it's about 100 seconds before it gets to that 100-kilometer altitude where it starts the maneuver. It'll be in position at about 150 seconds, something like that, where it will start releasing the chemical. The whole flight, I think, is maybe 480 seconds, something like that, for the entire flight. So it's really not a very long flight, just a few minutes, maybe 8 minutes, I think, total.
Hi, my name is Veronica Fake, and I was wondering what the HEX mission is and how can kids get involved?
Well, the HEX mission is an experiment to measure how the Aurora heats the atmosphere and mixes the atmosphere vertically. At the height that we're looking at, which is about 160 kilometers, the atmosphere settles out into the composition of the atmosphere is no longer constant. The heavier gases settle lower in the atmosphere and the lighter gases sit higher. And there's really nothing that would mix that apart from the heat of the Aurora. And that mixing appears, or it operates through vertical winds blowing up and down, the same way as the convection from a candle flame causes the air to move up and down. And we want to measure that. So what we want to do is we want to fly this rocket through the Aurora, deploy a trail, and map how the winds are moving vertically in response to the heat of the Aurora. It's called HEX. The H in HEX stands for horizontal because we're going to deploy this trail horizontally, and the E and the X stand for E region experiment. The region where the heating occurs is a region of the atmosphere called the E region, and so we're trying to measure the mixing in the E region. The way that kids can get involved, at least here in Alaska, is that we have kids who are living out in the remote parts of Alaska underneath the trail, and they're perfectly positioned to photograph the trail for us, and so we're asking those kids to help us out by taking some photographs.
Good morning. My name is Kelsey Bennett, and my question is, why do you have to fly the Hex rocket horizontally?
There's really two answers to that. One is that the trail that we deployed, we're looking for vertical movement of that trail, and if the trail was not horizontal, let's say it was standing vertically in the atmosphere, the movement would be along the trail, and you really wouldn't see it. It would just be this long, thin thing moving along its own length, and you wouldn't see it. But by sitting it horizontally, the movement's then across the trail, and that's easy to see from the ground.
And I'm going to pass back to Art, who's got a special guest to introduce to you.
Oh, thanks, Nikki. Well, we've got Shannon here again to tell us some of her experiences.
Okay, I think we're going to see a tape of one of the launches that I was a crew member on. And actually, this was the one that you're seeing right here was the second flight that I made. And this was the first time that I was able to see an aurora from space. Actually, I think it's very interesting that I saw an aurora from space long before I ever saw an aurora from Earth. As a matter of fact, I never saw an aurora here on Earth until last week when I was here in Fairbanks. The last flight that I was up on was when we launched. We went out once again to the shuttle and we launched up to the Russian space station Mir. Now, when I was strapped into the space shuttle and we launched, I thought that I was leaving Earth for 4 months. Little did I know that I would be gone for 6 months. And I was going to stay on Mir for an extended period of time with my two Russian crewmates, Yuri Anafarenko and Yuri Usachev. Now, of course, it was sort of sad to see the shuttle leave with my friends, but I was also very happy to get started on the long mission that I was going to spend in space. This is what Mir looked like. Leaving from the docking compartment, you would go down through a tunnel and go into the other parts of Mir. Now, another thing that we had to do every day while we were on Mir was to exercise, because we had to make sure that the body we were going to come home to was fit to come back to. At the end of every day, what I like to do was take about 30 minutes or an hour and just sort of curl up, float with a book, and read. Because all day long we had been doing many different types of science experiments, and we were working pretty hard, and we never had too much time for breaks like that. But there were a few times when we would be able to take extended periods of time and go look out of the window, and at those times we were able to see the stars, the Earth, and one day I was able to see auroras both in the northern hemisphere and the southern hemisphere. So I thought that was sort of a very special day when I was able to see this type of activity in both hemispheres. This is a picture of an aurora from space. This was taken by Don Pettit, who is currently up on the International Space Station. He's a science officer on the space station, and he spent his Saturday. He was so thrilled at being able to see this aurora that he took extra time, his off-duty time actually, to take these pictures. And these are a little unique in the fact that finally we have cameras up in space where we can take colored movie videos and get the videos of the auroras.
That sounds really exciting. Okay, we have some questions now from April.
Okay, I was wondering if when she was up in space, were the auroras looking any different than they did down here on Earth?
When I was up in space, I think every aurora that you see is slightly different. Now, I've only seen them one time from Earth, and that was just a night ago when I was here in Fairbanks. And the one thing that I saw that appeared to be quite a bit different here versus the time that I was up in space was that the auroras seemed to be much more active. I was surprised at the amount of activity and how fast they were moving. But I think that this is just the way that this particular aurora was. Actually, when I was in space and I would look down and I saw the auroras, I remember the first time I saw it, I thought it sort of looked like witch's hair that was hanging down, you know, coming down from the universe onto Earth.
I'm Allison, and I was wondering if when you're up in space, if there's a color difference from where it looks like on Earth.
It was different kind of colors. In space, the predominant color was green, but I did see a little bit of blue, a little bit of red. But the one thing that I noticed, it was so beautiful from space. And of course, we quickly grabbed our cameras and we took pictures. And then when we got back to Earth and looked at the pictures, we were so disappointed because the pictures didn't do justice to what we had actually seen.
Hi, this is Lincoln from Anchorage. We have one question first from Christine, 15 years old, who wants to know, Shannon, is it fun to work in space?
Well, Christine, it is an absolute blast to work in space. And the thing about being on Mir that was so neat was, number one, I was being able to work in space, you know, being in microgravity. You could float around, you could kick off from the ceiling or kick off from the walls. And the other thing was that I was really working in a laboratory. And, you know, I love flying, I love being in space, I love working in a laboratory, so it's sort of the best of all worlds where you could combine everything that you really enjoy doing in one situation.
Okay, and now back down to ground. Dan, would you like to tell us what we're seeing at the moment on our cameras?
Well, what we have here right now is a large mass of aurora covering the entire sky in a very diffuse, undefined sort of a thing. It's a great glow that turns the entire sky kind of a low green. So we don't have any bright, discrete arcs which are typical of what everybody loves to see. But let's roll to the other package of tape here. This arc here is nice and sharp and well defined. That's what we mean by a discrete arc. So just imagine lying on your back and looking straight up at this, because that's the way the aurora goes. And this aurora here is the Great Red Aurora of March 13th, 1989. This aurora also was seen as far south as Cancun on the Yucatan Peninsula in Mexico, and got many telephone calls from various chief of police around wondering what was going on. Looking on up here slowly on this same aurora, this was later in the evening on the same night on the March 13th, and as the camera tilts up slowly here, you'll see what we call a corona. You'll be looking straight up, lying on your back, up into the sky. And remember that those lines coming towards you are all perfectly parallel. It doesn't look it, but they are parallel. It's just that they are so incredibly long going up into the sky where the particles are coming down and lighting those channels coming down. So here we are, back to you, Nikki.
Thank you. And as you know, we've got rockets on the launch pad. It's a great deal of excitement here. So let's go down to the blockhouse and get a mission update from one of the mission managers. Greg?
Yeah, well, we just scrubbed the Jewel mission about 2 minutes ago. And Bruce, can you tell me just why and where we're at with that?
Well, we just didn't quite get this proper science conditions tonight. The scientist just called me a few minutes ago. Still had cloudy skies over some of the uprange camera sites, and didn't quite have the current in the aurora that he was expecting. So, well, we'll come back tomorrow night and give it another go.
Okay, sorry about that tonight.
Well, we're sorry too, but thank you very much for the update. And now I think Art has some science for us.
We're going to go into the next room now, and Miguel is going to show us his Joule experiment and give you some idea of the physics of that. So, your rocket just got scrubbed. I'm kind of disappointed. I assume you are too.
Well, we all want to see it launched, and of course we did our best tonight to try to do that, but sometimes conditions are just not right.
Yeah.
And what we're looking for is something called Joule heating. And Joule refers not to jewelry, but to the famous physicist James Joule, who lived in the 1800s. And he was the one who discovered Joule heating. And specifically what it refers to is, in fact, like this. If you have a current flowing through a resistor, like this filament, it produces not only the light that you see, but also heat. And if you hold your hand close to a light bulb, of course you detect the heat with your hand. And the aurora is very similar, because when you see the light displays, there are also currents, electrical currents, flowing through the atmosphere. And those currents produce heat, just like in the light bulb. And the amount of heat is roughly equivalent to a 100-watt light bulb in an area 100 feet by 100 feet. So if you think of the atmosphere as being divided up into these square regions, 100 feet on a side, there would be a light bulb in each one. So you can sort of imagine, thousands and thousands of light bulbs in the upper atmosphere, all producing heat. But in spite of the fact that we know that the heating is there, we don't know for sure how big it really is. And that's what we're here to measure. One of the effects of the heating is to make the atmosphere expand. So when it gets warm, it basically grows. The envelope around the Earth becomes bigger. And that affects the orbit of satellites, for example. So we need to know what the effect of the heating is so that we can better understand how spacecraft are going to be affected by this.
Okay, what we'd like to do now is show you a tape of some of the preparation for the Joule mission.
Night 2 of the Joule mission's launch window. It's about midnight, but unseasonably warm. Just about 0 degrees. Shirt sleeves weather for Scott from NASA Wallops. He and Paul are in charge of the test rockets, which Poker Flat sends up on potential launch nights.
He's going out. Take your time, be careful out there.
It may be warm, but it's slippery outside, and these are highly explosive. Each rocket is carefully placed in its launch tube, with electrical connections running back to the blockhouse.
This is the rocket motor ignition here, and that's the rocket flare. Scott's doing.
Nothing is rushed. Each step is deliberate and careful. Mark Conde's Hex rocket and the chemical release rockets shared by both missions are almost ready.
Definitely in a big hole.
Pad 2 power. Power's on. Power indicator's on. Fire relay safe's on. Armed is off. Fire switch safe is on. Turning the key. Oh, I hear that. I sure can.
In the blockhouse, Marty Martinez makes sure the rocket motors will have power when the buttons hit. One final test.
3, 2, 1.
Next time that button's pushed, they all hope it'll be for real. Each of the 5 launch pads has a rocket.
OC, MC, Channel 2.
Go ahead.
We're ready to pick up the count.
Joule mission manager Bruce Scott leads the Wallops and Poker Flat teams through one of several practice countdowns.
5, 4, 3. Item 31.
Check item 32.
0.
The Wallops team carefully monitor the all-important science instruments. Outside, unusually bright northern lights dance over the launch pads. Up the hill outside the Science Center, undergrads from Clemson in South Carolina brave the cold to see their first Aurora and capture it in photographs.
Well, right now there appears to be 2 pretty distinct ribbons across the sky, and then beyond that sort of looks like a big clump, and you can actually see that one moving quite a bit, and it's quite something. It's all green right now, and certainly like nothing I've ever seen. Getting lots of pictures of it and send it to all my friends. Look what I get to see. You're in class. Well, I mean, some of the things I've seen in the books have been a lot more colorful and more distinct, but you know, it certainly beats anything just seeing it in person.
Here at Poker Flat, the Aurora's looking pretty promising.
Maybe I could just ask each of the people there to let us know.
Mark Conde runs a telecon with the observing sites, whose photographs will be critical for mission success.
The skies here are cloudy and it's snowing.
That doesn't sound good.
That's not what I want to hear.
It takes at least 2 sites, plus Poker Flat, with clear skies. Mark and Miguel were hoping for the best.
Don't see any stars anymore. And as you can see from the sample pictures that I sent, it's essentially just gray outside.
Yeah, it looked to me like on at least the first one you sent there was a couple of stars I could see, but I guess it's deteriorated since then.
Yeah, it's clouded over again and got denser.
So at this stage, I guess we're just going to be waiting until closer to magnetic midnight, but at this stage, it's certainly worth holding on, I would say.
Absolutely.
Yeah, Miguel's concurring with that.
Well, I mean, there's still not much current, but certainly the display is pretty amazing.
Outside, the aurora is bright enough to lure Miguel away from the monitors and spectacular enough to delight first-time observer Jennifer, one of the Clemson undergrads.
I'm seeing beautiful green bands across the sky. Well, at first I was a little disappointed. I mean, not disappointed, but I was hoping it'd be more intense. But now it's definitely ranks up to my expectations.
We're in Launch Room B again with the Jewel mission students who've been helping work on this. And Jennifer, what have you been doing for this mission?
Well, mainly we're in charge of setting up the camera boxes to film the TMA release. We have 4 rockets going off, and 2 of them contain TMA, trimethyl aluminum, and we have 3 sites set up with camera boxes, and we're taking photos in sequence, and we'll be able to analyze the data measuring the wind profiles. And so we've been setting up the boxes to take pictures, as well as I've been calling the other 2 sites at Coldfoot and Fort Yukon, checking on the science update and how the weather is there. And so far we have not had clear skies, but we have had aurora activity.
So it was the skies that got us tonight?
Yes.
Oh, that's too bad. And Justin, what have you been doing on this mission?
Well, I've been getting the cameras out to the boxes every night, making sure that the times are all right, because we have to have the times imprinted on the actual photos so that we can get the data correctly. And that's basically been it, making sure everything's working out all right and waiting for the rocket to launch.
Well, and what they've been doing while they're waiting is doing their homework. I've been and they're surprised to learn that the homework they're doing is actually the same kind of physics problems I do in solving what's going on in the sun. So now we'd like to go to Baltimore. You have some questions in Baltimore?
My name is Olivia, and I'd like to ask why you need to launch 4 rockets for your mission.
Well, we need to launch 4 rockets because 2 of them contain the trimethyl aluminum and 2 contain the science experiments. And in order to find out the wind profiles at the given time, we have to be able to triangulate using geometry and find the wind profiles by the TMA trails. And so basically we have to launch them in about 20 minutes total, all 4 of them. And so that's how we compare the different data, and we're doing it the same time so that we can compare the different data.
Oh, that sounds like fun.
Hey man, my name is Sam, and I was wondering.
Sam.
Hey, I was wondering how you got interested in this field of study.
How I got interested in this field of study is the question. Basically, just going out and trying to get a feel for the program, and one thing led to the next. I don't have any real great inspiration other than just curiosity. That'd be my answer to that one.
I think that's the big answer on science, curiosity.
Yeah.
So now I think we'll go back to Dan to see if there's an update with what we're seeing.
Well, we're in for a very rare treat here. The aurora is actually going to cooperate very well before we run out of program tonight. We have some aurora that is getting brighter in the sky. I'm going to run the camera along it so you can see how big this is. This is just covering the entire sky here with a nice arc. And it is moving along fairly rapidly, so I'm having to chase it a bit with the camera. And hopefully we'll see some nice bright movements in here. Up in the zenith it is moving even more rapidly. It is sweeping along towards us here. Not quite as bright as what we had earlier tonight, but it is still plenty good enough. You just watch it here slowly and it'll develop along, and it will break on up and swing. See, as it's moving across, you'll see the color changes. Now, I want you to remember that none of this is sped up. This is what really happens in the sky, so just kind of pretend that you're lying on your back looking at this aurora. Let me tilt the camera up further, just as if you're leaning back further. And here we're going to get some more motion in there. There we go. This is slowly sweeping across the sky here and making a great big loop. Let me see if I could widen the lens on the camera out a little bit here and kind of give you a bigger feeling for what's happening on the sky. I've got a zoom lens on this camera, and it's slowly curling over here towards the right. Near the top of your picture you can see the handle of the Big Dipper. So you can Imagine how much sky you're looking at. Remember, from one side of the image to the other, it's about 90 degrees across. Yeah, it's getting better on the left side there. Let me move the camera a bit further before we're going to lose some of this here off the image. And I think it's better down lower here. Let me just go trace this a little bit. Now, we'll go down and get this. You see a little red glow in the lower corner of your image, and that is mainly due to lights of Fairbanks shining off some clouds, and the sodium vapor street lights of most cities actually has a pinkish color to it. So it looks like we're going to end tonight with kind of a slow breakup. What a great close. I really hope that all of you have enjoyed the Aurora tonight as much as we have. So here we go, back to you, Nikki.
You know, one of the things that the team's been doing while they've been up here hasn't always been total work, I don't think.
We were able to go dog sledding during the day and watching the Auroras at night. You can't ask for much more than that. It turns out that the manager here at Poker Flat has a daughter, Nicole, who's a teenager, and she is really into dog sledding. They moved up here about 4 years ago, and a friend of hers had a dog and was racing it, and so she thought that would be so much fun, and so that she got started doing that. And now she is an expert handler of the dogs. You can see the dogs were very enthusiastic as they took them out of the truck and harnessed them up, and they were ready to go. And so Nicole offered to give me a ride on a dog sled. Now this was a first for me, and it was amazing. The dogs just took off, and you just felt like you were whizzing across the earth. Now I thought it was very, very interesting to sit there on the sled and watch the dogs run and watch the rhythm as all the dogs ran together and the teamwork that was there. I was also very impressed that Nicole, who is just a teenager, was able to control this team of dogs. And she was able to control them with just voice commands. The other thing that really impressed me was how cold it was outside. And it was even colder with the wind that was generated as the dogs were running down the trail. But we just thoroughly enjoyed it. And I hope someday I'll be able to go on a dog sled again. Well, it was just like whizzing down the mountain. You know, you're going about 20 miles an hour. It sort of gave you the feeling like you're flying in an airplane, very, very low, you know, just skimming the ground. It was really neat. And I really enjoyed watching the dogs, watching how they were using their legs and how they were using their bodies to pull the sled. I just thoroughly enjoyed it.
The dogs are athletes, and you are kind of, because you guys weren't behind me then, but like with the extra weight in the sled, I was pushing 1 foot behind the sled, and that kind of helps them go, and then they're running. I don't know, but I think it's harder than like playing football or something.
Experience to be able to be in a dog sled, and I just want to thank Nicole for giving me such a wonderful taste of life in Alaska.
But now we're going to give you the chance to ask Dan a couple of questions. So Baltimore, would you like to go ahead?
My name is Lolita, and I'd like to know what interests you most about the Auroras.
Well, actually, I'm going to cheat on that question. I think I'm extremely lucky because I get paid to look at such a beautiful phenomenon as the Aurora, and it is so intriguing scientifically. That is very interesting about it because there's so much that's unknown. But anytime that you get a chance to work around such an unusual phenomena and get to live with it, I know it's terrible work at night. You're up all night doing it, but it's well worth it when you see a fantastic display like we did tonight.
Okay, and another question from Baltimore.
Hi, my name is Tria, and my question is, if you could touch an aurora, what do you think it might feel like?
Well, that's a very good question because up at high altitudes, everybody assumes it's very cold. But up where the aurora is, actually the molecular temperature, in other words, the temperature of the individual atoms that are vibrating, is actually almost room temperature. You could run around in short sleeve shirts if it wasn't space and didn't have enough air so you couldn't breathe. So you probably wouldn't want to ever take your hand out of the spacesuit and touch it. But on a molecular level, it's fairly warm. So that's that.
Yes, thank you. And over to Oakland. Do you have a couple of questions for us?
I'm Will Geffen, and does the temperature affect the aurora?
Well, the temperature doesn't affect the aurora. A lot of people think that when it's cold in Alaska, the aurora is much better and brighter. And the real truth is that when it's clear skies in Alaska in the wintertime, the heat escapes from the earth and it gets very, very cold. So mistakenly, a lot of people assume that cold weather brings on auroras. It's just that you could see them better.
And it is cold, let me tell you.
No, it's not.
See, they think it's warm, but you know, you guys in Oakland, you would be freezing here, trust me.
Okay, I'm afraid that's it then.
We should go to Greg.
Yeah. Oh, right. Sorry, Greg, you're at the blockhouse?
So from the blockhouse, I'd like to say good night to you, and study your math and science, and maybe you'll be up here as one of these engineers or scientists with us in the future.
Thanks, Greg. Although you guys aren't going to be able to see a live launch, we do have one on tape that's really exciting to watch. So we're going to let you watch a rocket launch.
Unlike the space shuttle, a sounding rocket immediately sprints upwards from its launch pad, traveling at about 40 meters a second. The payload, with its science instruments, continues upwards into the Aurora, completing its mission in just a few minutes before falling harmlessly back to Earth.
Okay, I want to say goodbye to everybody. And you've watched us tonight, and you can keep track of what we're doing on the web.
This is Lincoln from the Planetarium, and we're saying goodnight from Anchorage, Alaska. Good night!
Okay, for Live from Aurora, this is Goodbye from Atlanta and our Aurora cookies. Guys?
And now we'd like to say goodbye to Baltimore, so bye.
We're saying bye from the Maryland Science Center in Baltimore. Bye, guys. Thanks for including us. We had a great time.
Goodbye, and over to you, Oakland. Bye-bye, Oakland.
And we just want to show all you kids what you have to dress like to go outside here. It is cold.
Okay, so with that, it's goodbye from Poker Flat.
And bye from Live from the Aurora.
Don't forget to join in with Sun Earth Day on March the 18th.
Watching the aurora and launching rockets both depend on weather here on Earth and up in space. Neither Mark Conde's Hex rocket nor Miguel Larsen's Joule mission made it off the ground in their first launch window. Both are back at Poker Flat and hoping to launch beginning March 19th, 2003. Check out the Sun-Earth Connection and Sun Earth Day 2003 website for links to all the latest. Check out more comments from Art and Nikki. Find live links to all the latest solar science and much more. With your curiosity and your computer, anytime, anywhere, you can continue to be live from the Aurora. Live from the Aurora is made possible in part by NASA, the National Aeronautics and Space Administration.